Section 3.4, atomic number and mass number. Or we could say this is the section that's going to tell you what the two different numbers mean or represent. As you look on the periodic table at each element, you will see two different sets of numbers. That's what this means, and that's what this section's all about. So first of all, the atomic number is very specific for each element. It is the same for all of the different atoms of that particular element. And that number is equal to the number of protons in an atom. And so if there's only one number there, then our atomic symbol, atomic number 11, that also represents 11 protons. And so if you look at the periodic table for hydrogen, the number there is 1, which tells us that for every hydrogen atom it has 1 proton. Atomic number of carbon is 6. You look on the periodic table, there's a 6 there. Every carbon atom has 6 protons. Copper, you look at copper, number 29, so every copper atom has 29 protons. Now remember, protons are of a positive value. They have mass, but they're also positively charged. Well, if they're positively charged and atoms are neutral, then there's something else hanging around in that atom, and of course we know it's electrons. So since the overall net charge is 0, however many protons, i.e. positive things you have, that's the same number of electrons, negatives. So for example, aluminum has 13 protons. So that means it must have 13 electrons. Why? 13 positives and 13 negatives has a net overall charge of 0. Let's go back a couple slides and talk about hydrogen. Well, if there's 1 proton for hydrogen, then we know there's 1 electron because 1 positive needs 1 negative to balance it out. Carbon, 6 positives needs 6 negatives, i.e. 6 electrons. For copper, 29 positives. Protons need 29 negatives, i.e. electrons. So we know then that for an atom, because atoms, the net charge is 0, then however many protons there are, that's equal also to the number of electrons. So let's go ahead and put it on pause and see if you can figure out the atomic number, the protons, and the electrons by looking at the periodic table. All right, so nitrogen's atomic number is 7, which means that's how many protons there are. Since protons are positive, then we have 7 electrons, which are negative, to balance out. We can say the same for zinc with 30, then that means we have 30 protons, 30 electrons. Sulfur, we have 16 protons, and we have 16 electrons. Now, the mass number, though, is the other number there that is represented. It's equal to the number of protons and the number of neutrons. It represents the number of particles that's in the nucleus. It is always a whole number. So when you look at these, we look at this chart. Now then, let's look at chlorine. So we go down. The atomic number is 17. The mass number is 37. So because there are 17 protons, we know there's 17 protons and 17 electrons. And you might think, well, 17 and 17 and 17, but no, there's 20. So why is it not 17? Well, that's because neutrons are neutral, so it has nothing to do with that. It has to do with the particles in the nucleus. And so neutrons are neutral. Neutrons and protons are in the nucleus. So protons plus neutrons is the mass number. So in other words, in order to find out how many neutrons you have to take the mass number minus the proton number, i.e. The atomic number, and you will get the number of neutrons. Well, wanted to point out another word that we need to use in another section. you need to realize that the mass number is different for different isotopes of an atom. Now, at the moment, you have no idea what an isotope is, so let's wait till the next section. But right now, in order to find the number of neutrons, we have to take the mass number minus the proton number. So, here we go. An atom of lead has a mass number of 207. How many protons are in the nucleus? Well, go to look at the periodic table, and when you scroll down to the periodic table to lead, you see it's 82. And you see that there's two numbers on there if you're looking, 82. All right, so that means there are 82 protons. Now then, let's answer C while we're at it, because however many protons there are, we need that many negatives, that many electrons. So we have the same number, which again, when you look at that, that's 82 electrons. So then the next question is how do you figure out the neutrons? We'll go 207 minus 82, and there is your answer for your neutrons. And so this next slide shows that and that.